is Mark Todd. I wanted to take you on a quick tour of some of the lab work that we do to create screens. Built right here in Massachusetts. I'm up here at the lab bench. I'll give you a quick tour. I have the 2-port device running up onto the screen, and it's being controlled by the controller, as you've seen in the videos. First thing I wanted to address was that I've heard a lot of people say, well, that's just picture-in-picture. And I would say to that response is absolutely, it's picture-in-picture, like this. This is picture-in-picture, and this is traditionally how you would have it, a full screen and then some picture that you couldn't move. You couldn't do anything with it. So we're more than picture-in-picture. We like to think of ourselves as picture and web and convergence. So for example, if I move this and resize it, I can perform and allocate pixels however I want on my screen. So there's one big difference between picture and in-picture. Picture-in-picture just gives you picture-in-picture with a lot more functionality. Layouts are another one. So for example, if I were to choose a custom layout like this one, for example, that might be, in this example, ABC. You have linear content and you have ABC application content. That kind of shows you the difference between picture and picture. This is not exactly picture in picture, it's a converged image, and convergence is how we see going forward that you're going to be able to change your converged images and interblend elements of, for example, Twitter, what ABC wants you to see, plus their linear content that may be coming out of a cable box. And again, you can make them more sophisticated. For example, this will be NASCAR, where I can create NASCAR targeted advertising and overlay a GoPro camera, which is up here, and then this is my signal source. I'm driving it with a 1080p 60 image, and that's how I can kind of drive and test the unit. It's not so much a processor or a DSP or things that you might find in a PC or a PCI card. This is a what we call reconfigurable technology. It's an FPGA, and an FPGA is good because it's like Lego blocks for transistors. So by using software, I can change the orientation of the transistors and get hardware line speed parallel operation. That is significantly important for our architecture because each one of these videos at 1080p generates about 4.5 billion bits per second. And each HDMI input has to digest 4.5 billion bits per second simultaneously without affecting the other, and then we generate that 4.5 billion bits a second back out, and we do it in a frame time. We actually didn't start out with this nice little small one. We actually have been working in our prototype versions, and let me show you this. We have an internal code name for this guy. It's called Prometheus. This is obviously much bigger, and this guy has more power supplies, and it has ADI chips, and it has a coprocessor off to the side. That's an ARM core, and this is a big honkin' FPGA and the RAM. And so the flow of this is we wanted to be able to get simultaneous HDMIs at any scale, in and out. And so this unit here, the core design of the FPGA and the operating system run on this as the same it does on this. This is just scaled. And this is what allows us to make different shapes of the board. The 2-port, the 4-port, what have you. Another interesting thing about the difference between the 2-port and the 4-port is that the actual chip, it's not just 2 extra HDMI ports in the 4-port, but the actual Lego blocks, the number of Lego blocks of transistors in the FPGA is more than double. Okay, great. Like any good electrical engineer or any good electrical lab, you always have your Dunkin' Donuts coffee. We spend a lot of late nights inside this lab debugging, and we have a great engineering staff. On the web staff, on the web page, you'll see our team, and it's made up of a lot of senior engineers. I kind of work as the integration engineer. I pull all the concepts together and I test them, and I, get drops from the user interface guy. I get drops from the, excuse me, code drops from the firmware guy and the FPGA guy and the team, and then the hardware engineers, the layout engineers, the mechanical design engineers, software engineers on the back end that's serving some of this internet content. So we have a lot of members backstage that are not in front of the camera here, but you should, we have a substantial engineering presence. I've heard mentioned before that hey, this is just like an HDMI router or an HDMI switcher. Sure, it can perform the task of HDMI switching, right? I could take HDMI 1 and take it out and push it out, HD output HDMI. I can take HDMI 2 and push that out, HDMI. An HDMI switcher, $150. That's all it can do. You can't watch a football game and watch play your Xbox, for example, at the same time. That's why this is hardware blending. The hardware blending is the secret sauce, is that technology inside this chip that again will swallow massive amounts of bandwidth without impacting the performance, which is why you see no lag. And any lag that you would see tends to be the IP network, or in my lab, however my system is set up. The chip is performing these register sets instantaneously, very, very quick, instantaneous to us. The question I had asked of me was, why are we doing a Kickstarter? We're doing a Kickstarter for two big reasons. The first is that we need volumes to bring these units out in volume, and I'll show you this at a later video snippet. Our production line needs so many thousand units to run through it to get the cost down. So I need volume to get the cost down. And the second reason is I need Kickstarter folks. I need people who show customer adoption, show that, say, look, hey, we want to kickstart this company. We want this thing. We want this thing going forward. We see potential in this for streamers. We see Twitch. We see YouTube. We see potential for, I've heard a lot of people say, look, IT departments. Look at the number of screens around this place. The number of screens and screening elements that you have is growing out of control. We need a new type of platform that allows us to take bigger screens and get much more control of our pixels. So I'm looking for people to help us kickstart this and be kind of part of it, and you will be part of it. I'm taking feedback and taking input. This isn't hardware that's made over in China, or it's made somewhere else. Somebody else designed it, and I'm taking it and adding code on top. This is the real deal. This is as significant as it gets. This is the same level technology that I would use to make a 10 gigabit switch or a 10 gigabit router, or a piece of core equipment, a fiber optic core. And all of our guys that work on the project come out of those spaces, which is why the level of technology that we had to put into this to change the way the platform works was so significant.